1. What is the universe made of? Astronomers are confronted with a perplexing dilemma. They lack knowledge about 95% of the universe's composition, while atoms, the building blocks of everything visible, only constitute a mere 5%. Throughout the past 8 decades, it has become evident that the significant remainder consists of 2 elusive components: dark matter and dark energy. Dark matter, initially detected in 1933, serves as an invisible force, binding galaxies and galaxy clusters together. Dark energy, unveiled in 1998, propels the universe's expansion at accelerating rates. Astronomers are progressively unraveling the true nature of these concealed entities. 2. How did life begin? Approximately 4 billion years ago, a significant development occurred within the primordial soup. From a few simple chemicals, biology emerged. The initial molecules capable of self-replication surfaced. As humans, we are evolutionarily connected to these early biological entities. However, the spontaneous organization of basic chemicals into lifelike structures on early Earth remains a profound mystery. How did DNA come into existence? What were the characteristics of the first cells? Despite more than half a century passing since chemist Stanley Miller proposed the primordial soup theory, consensus eludes us regarding the exact sequence of events. Some argue that life originated in hot pools near volcanoes, while others suggest it was triggered by meteorite impacts in the ocean. 3. Are we alone in the universe? Maybe not. Astronomers have been extensively searching the cosmos for celestial bodies where water worlds could have fostered life, ranging from Europa and Mars within our solar system to planets situated light years away. Through the utilization of radio telescopes, they have been listening in on the cosmos, and in 1977, a signal containing potential indications of an extraterrestrial communication was detected. Presently, astronomers possess the capability to analyze the atmospheres of distant planets for the presence of oxygen and water. The forthcoming decades promise to be exhilarating for those engaged in the pursuit of extraterrestrial life, given that there may be up to 60 billion potentially habitable planets solely within our Milky Way galaxy. 4. What makes us human? Simply examining your DNA won't provide all the answers. Human genetic makeup is remarkably similar to that of other species. For instance, we share 99% of our DNA with chimpanzees, and even 50% with bananas. However, humans do possess larger brains compared to most animals. While our brains are not the largest, they contain 3 times as many neurons as those of gorillas, totaling approximately 86 billion neurons. Many traits once believed to be uniquely human, such as language, tool usage, and self-recognition, have been observed in other animals as well. It's plausible that our culture, and its reciprocal influence on our genes, plays a crucial role in setting us apart. Scientists theorize that the advent of cooking and mastery of fire might have contributed to the enlargement of our brains. Nevertheless, our ability to cooperate and engage in skills exchange could be the defining factor that distinguishes humans from apes, shaping this planet as a domain primarily inhabited by humans. 5. What is consciousness? Our understanding remains incomplete. However, it appears that consciousness involves the interconnection of various brain regions rather than being localized in a single area. The prevailing notion is that by unraveling the specific brain regions involved in comprehending the workings of neural circuits, we may uncover the emergence of consciousness. This endeavor could be facilitated by advancements in artificial intelligence and efforts aimed at constructing a brain neuron by neuron. Nonetheless, the more challenging and philosophical question pertains to why anything should possess consciousness at all. A plausible explanation suggests that through the integration and processing of vast amounts of information, along with the ability to focus and filter sensory inputs rather than merely reacting to them, we can discern reality from illusion. Furthermore, this cognitive capacity allows us to envision numerous potential future scenarios, thereby enhancing our adaptability and survival prospects. 6. Why do we dream? Despite dedicating approximately 1/3 of our lives to sleeping, our understanding of sleep and dreams remains incomplete. While some subscribe to Sigmund Freud's perspective, viewing dreams as manifestations of unfulfilled desires, often of a sexual nature, others question whether dreams are merely the result of random brain activity during sleep. Through animal studies and advancements in brain imaging, a more nuanced understanding has emerged, indicating that dreaming may serve purposes beyond mere randomness. Research suggests that dreaming could play a role in memory consolidation, learning, and emotional processing. For instance, studies on rats have demonstrated that they replay their waking experiences in dreams, aiding them in tasks such as navigating mazes. This suggests that dreaming may serve a functional purpose in cognitive processes. 7. Why is there stuff? Your existence is a puzzle. You're composed of matter, which has a counterpart known as antimatter, differing only in electrical charge. When matter and antimatter collide, they annihilate each other, releasing energy. According to our best theories, the Big Bang generated equal amounts of both, suggesting that all matter should have encountered its antimatter counterpart. leading to their mutual destruction and leaving the universe filled with only energy. However, nature seems to exhibit a subtle preference for matter, as evidenced by your existence. Scientists are diligently analyzing data from experiments such as the Large Hadron Collider in an attempt to unravel this mystery. Leading theories, such as supersymmetry and neutrinos, are being explored to understand why matter dominates over antimatter in the universe. 8. Are there other universes? The universe we inhabit is remarkably improbable. Even minor adjustments to its parameters would render life as we know it unattainable. To address this enigma of fine-tuning, physicists are increasingly exploring the concept of alternative universes. Within the framework of a multiverse, where an infinite number of universes exist, every conceivable combination of settings would manifest somewhere. Consequently, we find ourselves in a universe where conditions permit our existence. While this notion may sound far-fetched, evidence from cosmology and quantum physics is gradually aligning with this hypothesis. 9. Where do we put all the carbon? Over the past couple of centuries, our activities have led to the accumulation of carbon dioxide in the atmosphere, primarily through the combustion of fossil fuels that release carbon previously stored beneath the Earth's surface. Now, to mitigate the consequences of climate change, we face the challenge of reversing this trend by sequestering carbon dioxide. Various proposals have been suggested, including storing it in depleted oil and gas reservoirs, or depositing it in the deep ocean. However, the long-term stability and potential risks associated with these methods remain uncertain. In the meantime, it is imperative to safeguard natural carbon sinks, such as forests and peatlands, which store carbon over extended periods. Additionally, transitioning to sustainable energy sources that minimize carbon emissions is essential to mitigate further exacerbating the issue. 10. How do we get more energy from the sun? With fossil fuel reserves dwindling, the quest for alternative energy sources has become imperative. Our closest star, the sun, presents several potential solutions. Currently, we harness solar energy to generate power, utilizing sunlight directly. Another innovative approach involves utilizing sunlight to split water molecules into oxygen and hydrogen, offering a clean fuel option for future transportation needs. Furthermore, scientists are pursuing nuclear fusion as a promising energy solution, aiming to replicate the processes occurring inside stars. The goal is for these diverse solutions to fulfill our energy requirements sustainably in the future. 11. What's at the bottom of the ocean? 95% of the ocean remains unexplored, leaving us to ponder what lies beneath its depths. In 1960, Don Walsh and Jacques Piccard embarked on a groundbreaking journey, descending 7 miles to the deepest part of the ocean in pursuit of answers. Their expedition pushed the boundaries of human exploration, yet offered only a glimpse into the mysterious realm of the seafloor. The challenges of reaching such depths compel us to rely primarily on unmanned vehicles as scouts. The discoveries we've made thus far, ranging from peculiar creatures like the barreli with its transparent head to potential medical breakthroughs derived from crustaceans for treating Alzheimer's, represent merely a fraction of the enigmatic world concealed beneath the waves. 12. What's at the bottom of a black hole? The inquiry remains unanswered due to our current lack of adequate tools. According to Einstein's general relativity, the formation of a black hole from a dying, collapsing massive star results in a continuous collapse until it forms a singularity, an infinitely small, infinitely dense point. However, on such minuscule scales, quantum physics likely plays a significant role. Unfortunately, reconciling general relativity with quantum physics has proven challenging, as they have historically resisted attempts at unification. Nevertheless, a recent concept known as M-theory holds promise for potentially elucidating the enigmatic core of one of the universe's most extreme phenomena. Is time travel possible? According to Einstein's theory of special relativity, time travelers are already among us. For instance, astronauts aboard the International Space Station experience time ticking more slowly due to their high velocity. Although the effect is negligible at their speed, it suggests that with increased velocity, humans could potentially travel thousands of years into the future. However, nature appears less accommodating when it comes to traveling backward in time. Nonetheless, some physicists have devised intricate plans involving wormholes and spacecraft to enable such journeys. This theoretical framework could allow individuals to deliver a present to themselves on Christmas Day, or explore the profound mysteries of the universe. Is light a particle or a wave? The nature of light has been a subject of intense scientific inquiry for centuries. It exhibits properties of both particles and waves, leading to the development of the wave-particle duality concept in modern physics. In certain experiments, light behaves as if it were composed of discrete packets of energy called photons, demonstrating particle-like characteristics. For example, the photoelectric effect, where light striking a metal surface can eject electrons, is well explained by the particle nature of light. On the other hand, light also displays wave-like behavior, such as interference and diffraction, which are phenomena characteristic of waves. Interference patterns, for instance, occur when light waves overlap and either reinforce or cancel each other out. Therefore, according to the principles of quantum mechanics, light is neither strictly a particle nor solely a wave. Instead, it exists as a unique entity with dual characteristics, depending on the experimental context in which it is observed. Are there any massless particles? Yes, there are particles that are considered to be massless. One prominent example is the photon, which is the fundamental particle of light and other forms of electromagnetic radiation. Photons travel at the speed of light in a vacuum and have zero rest mass. Another example is the gluon, which is the mediator particle of the strong force that binds quarks together within protons, neutrons, and other hadrons. Gluons are also considered to be massless. It's worth noting that while these particles are considered to be massless according to current theories, there could potentially be other particles in the universe with mass that we have yet to discover or fully understand.